There is an error in this Python code and it can be fixed with one simple word. My name is Andrew. Let's find out what that is. So this mistake, this bug, this error appears in millions of programs and millions of programmers do not know about it. But it can be fixed with one simple word. Let's look at our code. So I have a list of users and each user is represented as a dictionary. So I have ID, name and age. So ID 1, name Andrew, age 15. Then we have update user function, and that is the function that has that error. We use update user in order to update the user in our users list or our users array. We provide ID, name and age as the parameters, and then we iterate through each user and we check that the ID of the user is the one that we supplied to our system, to our function. And then if the ID is correct, we update our name, we update our age. And here you can see the example. I print the initial users array and then I update the user with ID 1, so the first user in our case, and I change his name to Andrew new user. Then I print the users again. If we run that program, we can see ID 1, name Andrew, and the second one is Andrew new user. So I updated that user successfully. But what is the problem inside of update user that probably none of you see? The problem lies in the complexity of the algorithm. So if you haven't seen my video about big O notation, how we measure algorithms, I suggest you watch it after that video. But basically, when we want to say that the function is fast, it's optimized, it's useful in those terms, is that we want to count all the steps, and if the amount of steps is lower than some other algorithm, that algorithm is going to be faster. So basically, what we have to do here to get the complexity of our algorithm is to count all the steps that algorithm has. In our case, what are all the steps of the algorithm? Well, we open up for, we use if, users I, we change the users, and so on and so on and so on. And once we count all the steps, what we can do is use some kind of notations. There are lots of notations and all of that is math, but one notation that most of you know is big O notation. So big O is the worst possible case scenario for that algorithm. What's the worst possible case scenario for our update user function? The worst possible case scenario is that if we go through each user and we only update the last user, or we don't find the user that we need to update. So basically we go through each value inside of the list and update the last one, or we just don't find the user at all. The big O notation in our case is going to be O from N. What does N mean? N is the list length, so the length of our list users. And we have to make N steps in order to go to the last user or the user after that, so we don't find the user at all, and update that specific user. And of course you can say that, okay, what about that if? That's another step. What about that I initiation? What about the len function? It's another step. What about all of those equal to, is equal to, and all that stuff? We don't really want to count all the steps, we just want to represent it as a math function. So in our case, our math function is going to be O from N. We need to do N steps, in our case 3 steps, because we have 3 values in our users list, in order to get the worst possible case scenario of our algorithm. That's it. So most of you know about big O, and if you're still confused, then I suggest you turn off that video and watch my other video on algorithms. If you know about big O, then just watch it afterwards. So we have big O, and it's O from N. We can't really change it. I don't want to use some other algorithm like binary search or some other thing. But the thing is that we have more values than just big O. The next value I want to show you is omega. Omega. A Greek letter omega, I cannot write it with my keyboard, I don't know how to do that, but omega is the best possible case scenario of your algorithm. So big O is the worst possible case scenario. Omega is the best case scenario. And what's the best case scenario in our case? The best case scenario is 1. So omega from 1. Why is that? Because if the user that we want to update is the first user, we just update it and we stop our algorithm. You can see that the omega for update user is not really 1. Omega for update user is N. So what does that mean? That means that's the worst possible case scenario is O from N, and the best possible case scenario is O from N. So we can say that the only outcome of that algorithm is O from N. So we're going to have to make n steps no matter what, no matter the best or worst case scenario, no matter what we get in our algorithm. And why is it so bad? Because imagine that we have 1 million users in our users array. If you have 1 million users inside of that array, we're going to have to go through each user, even if the user that we want to update is the first one, the second one, the third one, and so on. So omega n is kind of bad. We want to make omega from 1, and of course, if we can, big O from 1 as well, because if we only have to make one step, then it's the best. But since we're using linear search, we can't really use O from 1, but we can use omega from 1. And once again, what we need to do is we need to stop the algorithm once the user is updated. And how can we do that? With only one word. That word is break. So what happened here? Before that break, we had to go through each user even after we updated our user right here. So what happened? If the user is the first one, so Andrew, we can see that ID is 1, so user from ID equal to the ID that we provide here in update user. So we update that first user, we change his name, and then what do? We don't stop the loop. So we go through user Tom, through Peter, through some other users, and so on and so on and so on. So that makes our omega O from n. But the thing is that you make n minus 1 steps. So you just make n minus 1 useless steps. Why is that? Because you updated the first user. You don't really need to update any other user. You already updated your user. Your ID is a unique characteristic. You already updated the only user that can have that ID. And then you're saying, okay, let's just go through each user that is left in our array, and let's just update, or sorry, not update, but just compare their ID to the ID that we provided here. We already know that that ID is not going to be equal to the ID of any other user, because we already updated our first or second or third entry. So we know that we make n minus 1 useless steps. And we don't really want to have omega as n, we want to have omega as 1. And how do we do that? With simple break. Because what happens when you break? What happens is that, or you can use return, because that's a function, but break is better. What happens with a break is that you break the execution of your loop. So omega becomes 1, because the best possible case scenario in that case is that if we look at the first user, and the first user is the user that we're looking for, we update it, we break. So we had to do one step. And that decreases the complexity of our algorithm by far. So we did just one word, we added one word. But our algorithm went from omega n to omega 1. So now if we have 1 million users, that doesn't mean that we have to go through each user in order to update a user. So any user inside of that array. We only have to go till n or till 1. So we have to make at least one step, but at most n steps in our algorithm. So that's it. And what I want you to do is go to your Python code, go to your Python programs, and look at the algorithms that should be stopped, but you don't stop them for some reason. You can use break, you can use continue, you can use return, you can stop your algorithms in any way you want, but make sure that you don't do unnecessary work. Nobody needs it, and that one word fixes a lot of hassle with our update user function. My name is Andrew. Subscribe to my channel, leave a like, leave a comment, subscribe to my Telegram channel. Thank you for watching, and bye bye.